All right. Hey guys, this is Mrs. Lyons, and we are going to work through the mole to mole conversions homework in your packet. So let's get going. Again, every time we do any kind of stoichiometry calculation, the first thing we have to do is balance our equation. Okay. So if I look at this, I can count. I only have one oxygen here. I have two over here. So I'm going to put a 2 here. That gives me 2 times 2 is 4 hydrogen. So if I put a 2 here, my equation's balanced. All right. So if 24.86 moles of water are produced, how many moles of O2 were needed to react? So my given is 24.86 moles of H2O. Now, once you get used to this, I don't care if you write the given and unknown. I'm just doing it so that as you're learning, you can go back and look and I can kind of explain where the things come from. So we're looking for moles of O2. So again, my mole ratio that I'm going to look for would be moles of H2O. So 2 moles of H2O to 1 mole of O2. All right, so I'm going to put down what I'm starting with, 24.86 moles of H2O. It's my given, always over 1. And then my conversion, I'm going to have 2 moles of H2O on the bottom and 1 mole of O2 on the top. So when I go to calculate this, I'm going to do 24.86 divided by 2. And I get 12.43 moles of O2. Okay. Number 2, if 8.63 moles of H2 reacts, how many moles of H2O are produced? So my given is 8.63 moles of hydrogen, and I'm looking for how many moles of H2O. Okay, so my mole ratio, I'm going to abbreviate MR, mole ratio, is moles of H2. 2 moles of H2 will produce 2 moles of H2O. Okay, so let's set this up. 8.63 moles of hydrogen over 1. And then I do 2 moles of hydrogen and 2 moles of water. Okay, now I know that this simplifies to 1, but I do ask you to put it in there so that I know that you got those numbers for the mole ratio from the coefficients of the balanced chemical equation. So this ends up just being 8.63 moles of H2. Okay. Let's see. If 15.59 moles of oxygen reacts, how many moles of water, how many moles of H2 would be needed to react? Okay, so our given is 15.59 moles of O2. Our unknown is moles of H2. Okay, so basically what we're looking at, just to kind of go back and revisit the idea of stoichiometry, you can do these kind of problems, can ask, it can start with reactants, it can start with products, it can have both reactants. Basically, it's a calculation that says, if I have this much of this element or compound, how much do I need to react? Or if I react this much, how much do I produce? Okay, so that's kind of the thinking behind this. Okay, so our mole ratio here would be 1 mole of O2 to 2 moles of H2. All right, so 15.59 moles of O2 over 1. We have 1 mole of O2 and 2 moles of H2. Our units cancel, so we do 15.59 times 2, and I get 31.18 moles of H2. All right, let's see. Here's a new equation. All right, so guys, I'm going to write this out for you because there's an interesting way to look at this, and I don't know that we have talked about it too much. So I want to show you something about some chemical equations when it comes to balancing them. There's a trick. When you're balancing something that has water in it, sometimes it's useful to write water as HOH instead of H2O. And I'll show you why. When we look at this equation, okay, see this OH here corresponds to the OH over here. And this H in our reactants corresponds to this H. So if I do this using tally method, okay, what I'm going to do is I'm going to write down I have aluminum, I have OH, which is called hydroxide, I have H, and I have SO4. Okay, this is going to make it way easier than trying to count up the oxygens and the hydrogens in water. Okay, so let's look at this. So here I have 3 aluminum. I have 1 aluminum, 3 hydroxide. I have 2 hydrogen and 1 sulfate, 1 SO4. Since SO4 shows up on both sides, we can keep it together. Okay, over here I have 2 aluminum. I only have 1 hydroxide. I have 1 hydrogen, and I have 3 SO4s. All right, so I'm just going to start with my aluminum. Okay, if I put a 2 here, now I have 6 OHs or 6 hydroxides. Okay, so let's go ahead and do the OHs. So I have 6 here. So if I put a 6 here, that gives me 6 hydroxides. It also gives me 6 hydrogens. Okay. Let's see. So let's go ahead with my hydrogen. Here I have 6 hydrogens. Here I only have 2. So if I put a coefficient of 3 here, 3 times 2 gives me 6 hydrogens and 3 SO4s. And if I look over here, oops, I messed it up. I had 3 to start with, so I still have 3. So 2, 6, 6, 3. My equation is balanced, and I have 1 aluminum sulfate. So my coefficients are going to be 2, 3, 1, 6. Okay? All right. So let's look at that. If 4.21 moles of aluminum hydroxide react, how many moles of sulfuric acid, H2SO4, react? All right, so my given is 4.21 moles of aluminum hydroxide. And I'm looking for moles of H2SO4. All right, my mole ratio is going to be 2 moles of aluminum hydroxide and 3 moles of H2SO4. Okay, so I'm going to write my given 4.21 moles aluminum hydroxide And then my mole ratio, I have 2 moles aluminum hydroxide. Remember, guys, the mole ratio numbers come from the balanced chemical equation. So just if you're wondering where I get these numbers from, right? And then on top, I'm looking for sulfuric acid. I'm looking for, moles H2SO4. Okay, so we're going to do this math. So 4.21 times 3 divided by 2 is I'm going to round that to 6.32 moles of H2SO4. Okay. Number 5, I'm given 1.62 moles of H2SO4, and I'm looking for how many moles of water, H2O. All right. So my mole ratio is going to be, let's see, H2SO4, 3 moles. H2SO4 is needed to make 6 moles of water, H2O. Okay. And we can write it as H2O now. We only write it as HOH when we're doing that actual balancing. All right, so I'm going to start setting this up. 1.62 moles of H2SO4, 3 moles H2SO4 on the bottom, and 6 moles of H2O on the top. Our moles of H2SO4 will cancel, and we are going to do 1.62 times 6 divided by 3. And I get 3.24 moles of water. Okay. So remember when we started talking about this being the math of chemistry and everybody was like, oh no, it's the end of the world. It's not bad. It's a process. And if you practice the process, it's actually pretty easy. I would say the hardest thing about doing stoichiometry is that you have to write a lot of stuff down. Okay, last one. If 3.7 moles of water are produced, how many moles of aluminum sulfate, how many moles of Al2SO4 3 are produced? All right, so our mole ratio, let's see, here we go. My mole ratio is going to be moles of water, so 6 moles of H2O and 1 mole of Al2SO4 3. All right, so my given 3.7 moles of H2O, so 6 moles H2O on the bottom, 1 mole Al2SO4 3 on the top. All right, we do the math. 3.7 divided by 6 is 0. I'm going to round that to 62 moles of Al2SO4 3. All right, so again, I want to stress the math is there. It's math, but it's a process. And if you practice the process, it's not that bad. It's actually pretty easy. But what's the key word? Practice, practice, practice. All right, guys, have a great day. I will see you in class.